So we're back to talking about characteristics of the graphs of rational functions. The thing that we're going to talk about right now are these holes. What the heck is a hole? That's what I want to know. So we're going to go to Desmos and we're going to check out how does a hole happen in a graph and what does it look like. So let's jump over here. All right, so the first thing that I want you to see is that I have three graphs up here, and you see right now this 1 over x, which is the parent rational function. It looks like this red graph and this blue graph are identical, but obviously I've changed it algebraically. You still see the 1 over x. What I did was I multiplied the numerator times x minus 2, and I also multiplied the denominator times x minus 2, but it looks as if those two graphs are identical. And then all I did right here on this one was just distribute to multiply this out, because usually the when you were provided a problem to work, it usually comes in this unfactored form. But you see, it looks like it's the exact same graph. And it is in all places except for this graph right here, the blue one, it has a hole. And in order to show you the difference, let me turn these two graphs off. These are the exact same graph. And I just want to show you the trace feature. As you can see right here, the trace feature shows all the x and y values as I move them along the branches, okay? And nothing mysterious happens here. We just have a whole bunch of ordered pairs, okay? Now, this one, I'm going to turn this one off. You'll see when I trace this one, something odd happens right here at x equals 2. I got to get on there exactly. Of course, it's going to be very hard for me to get on there. So let me try something different. Let me call this f of x. And now let me see what the value of f of 2 is. Okay, so what that tells me is that on that blue graph, f of 2 is undefined. And if I could get this to sketch over that at exactly 2. There it is. I managed to get it this time. So it's showing me that at 2, the blue graph is undefined. So let me turn the blue graph back on and let me go to the red graph and show you right here at this one. When the x value is at 2, the y value is at 0.5. It's 1/2. So these graphs are identical at every point except for the x value 2. And what happens right here, when you plug 2 in, you get 2 minus 2, which is 0, and 2 minus 2, which is 0. You have 0 divided by 0, and math kind of goes, I don't know what to do. I can't divide by 0. So it gives us an undefined value. So, and the same thing is true on the green graph. Let me turn the red graph off. In the green graph, if you trace over here to x equals 2, it is still undefined. So what I would do to show you the location of a hole on a graph, if I wanted you to see it, is I would physically have to come over here and graph the point, and I would have to graph the y value for that, for this graph, the one where after you cancel the common factors out, if you cancel out the x minus 2 and the x minus 2, it just leaves you 1 over x. Well, the y value, when you plug in the 2 on that graph, that's the location of the hole on your green graph. So I would simply come over here, make it green, make it an open hole, and then it would stay that way. So if I was going to do a screenshot of this, that would show you for sure that I have a hole, and you would have to know that the x minus 2 is the x value where the hole is located. So when you have common factors that cancel out on the top and the bottom, you're creating a whole. That's the takeaway from this video.